Hi class, this is Mrs. Cribb. This is my second time going through this, so I'm sure hoping we get it right this time when I'm recording it. I need you to pull up the periodic table of elements. It should have been given out to you in class by the assistant, and we're going to be coloring on that. And I also need you to pull up your notes. So if you haven't done that, please pause the video so you can go ahead and get that taken care of. All right. Now we're going to start working through these notes. So if you need to pause it, pause it. And I'm assuming it's going now. Introduction to quantum numbers. All right, quantum number is a way of describing the address or location of the electrons in an atom. Every electron has a different address. Pauli exclusion principle is one of those terms you need to know. No two electrons in an atom can have the same four quantum numbers. Honor students will be learning what these quantum numbers are, and for Gen Chem, you don't need to worry about it. But you just need to know what the exclusion principle is. There are different, these are determined by the energy of the electrons in the ground state. So remember, the ground state is the lowest energy state of the electrons. And think about it like sitting here on the ground, and then here's some steps, and here's my electron right here. Now let's use a different color, and he's kind of lazy. And then here comes along some violet energy, a photon of violet light maybe, and it takes it in. Now it's an excited electron, and it jumps up to energy level 3. Can't jump up in between. And there's now my electron sitting at the top right up here. But because it's lazy, it wants to fall back down, and when it falls back down, it has to release that photon of light. Okay, where it starts from is the ground state, the lowest energy state. Okay. Now, sublevels and orbitals. The s sublevel is one orbital can hold 2 electrons, and an s sublevel is shaped like a sphere. Think of just a ball, maybe even like a just like a kickball or something. It's mostly air on the middle, but it has this rubber on the outside. So that's sort of what the shape of the s sublevel looks like. The p sublevel has 3 orbitals in it, 3 orbitals, and those orbitals have different shapes. The first one is on the x-axis, and it looks like this, and that is one orbital right here. The second one would be on the y-axis. It looks like this, and that's the second orbital. And then the third one would be on the z, meaning coming in and out of the screen, and that is also one orbital. So we have a px, a p sub y, and a p sub z. 3 shapes, 3 sublevels, 3 orbitals for the p's. Each one of those 3 can hold 1 electron. 2 electrons. So 2 electrons in this one, 2 electrons in this one, and 2 electrons in this one. Okay, and the s sublevel can also hold 2 electrons. Now, so every sublevel can hold 2 electrons. The d sublevel has 5 orbitals, so every orbital can hold 2 electrons. And so 5 orbitals, 2 electrons in each, that gives us 10 electrons. The f sublevel has 7 orbitals, 2 electrons in each, for a total of 14 electrons. You can go back to another Prezi and look at the pictures in the textbook as well. These figures right here are showing you the shapes of these things, and you can see how strange they are. I can't draw the d and f, they're just too difficult. Okay. Relative energies of sublevels. As the energy of an electron increases, the distance of the electron from the nucleus also will increase. Think about twirling an object. When you twirl a rubber band, here's like a rubber band with an electron, and it goes around and around a certain distance. Well, if I go faster and faster, it's going to stretch that rubber band, and so now whatever object I'm twirling is way out here. It has more energy. So that's what this is kind of like. The energy level of an electron will increase. As it increases, the distance of the electron will also increase from the nucleus. It gets farther and farther away. The greater the sublevel, the greater the energy of the electron in each level as well. Okay, we're going to refer to the periodic table right here. This is not in your notes. This is what I pulled up in class. And you're going to now need to pull out your colored pencils and copy this into your notes. These all need to be the same color, and I want you to also add helium to this position, because for the purposes of electron configurations, Helium really sits in the S block. So you're going to have an S block, a D block, a P block, and an F block. And all 4 of those blocks need to be a different color. You will also notice that these 2 guys here are somewhere down over here in your periodic table. And it just has to do with the difficulty of writing in the actinide and lanthanide series. So I want yours to be the same color as whatever the D block is. So pause the video for a few minutes and go in and color code your periodic table. All right, I'm going to assume that you've done that now. And I'm going to also write in the energy levels. 1, 2, 3, 4, 5, 6, and 7. And then go straight across the chart to this side. And I don't think yours has these written in, so you may need to you have to write these in. 2, 3, see straight across from this 3, go all the way across. Still 3 on the other side. 4, 5, 6, and 7. And the weird thing is the middle section. The middle section, these yellow guys right here, they are transition metals. And the middle section has to go down on energy level. This is 3, 4, 5, and 6. Now I also want to show you that calcium is element number 20. So that means it has 20 protons and 20 electrons. And scandium is element number 21. So they're in order of the atomic number, the proton count. But right here, the energy levels go down. And in another video on the off-ball principle and one of the tutoring videos, I show you a picture of an off-ball graph of energy, and it helps you to see a little bit why these are like this. Okay, we're not going to deal with the F block because they become too complicated. All right, some things you need to know. So anyway, hopefully you got that done. If you haven't, stop it and get that done, then move forward with the video. So I'm assuming now you got it done, and I'm moving on. Electron configuration is a way of showing the arrangement of the electrons. So an electron configuration just says we have all these electrons and where are they located in the atom. And with the electron configuration, you've got to keep some things in mind. The off-ball principle. The arrangement of electrons in atoms is determined by adding electrons to an atom with a lower atomic number, that is one with fewer electrons. Lower energy levels are filled first, generally. Hund's rule. As electrons fill a sublevel, all orbitals receive 1 electron with the same spin before they begin to pair up. And so these will make more sense when I do the electron configurations with you. So you need to know off-ball principle and Hund's rule. I do believe they're in the study stack that I put up there for you. Orbital notation is used with electron configuration to show the position of the electrons. So electron configuration is a way of showing the arrangement, like where are they located, and the orbital notation shows the position. It's a shorthand for electron configuration. Chemists often write the symbol of the element that fills the previous energy level in brackets before adding the next sublevels. Okay, so let's get started practicing some of this. Helium is the first one, so I'm going to go up here and write it so you can follow me on the chart. Helium. Helium is right here. It's element number 2. That means it has 2 protons and 2 electrons. And those 2 electrons are in the first energy level. Okay, so how do we write the electron configuration for helium? First we show these right here are the energy levels. These guys right here are the N values, or the energy levels. So helium is in this first level, so it's 1, energy level 1. It's in the S block, and it fills up, it takes the first electron and the second electron, so 1s2. So what you do is you go as far as it can. Once it's filled, you would move to the next one. But this is all we need for the electron configuration for helium. And the orbital notation then is how many shapes does the S have? Remember, S, P, D, F, 1, 3, 5, 7. Hopefully you'll notice that S has 1, P has 3, D has 5, and F has 7. 1, 3, 5, 7. Those are odd numbers. So this shows you how many shapes they take. The S has that one sphere. Okay, so it has one shape, so I draw one line underneath. And then it has, we're using 2 electrons. So the first one we're going to say spins up and the second one spins down. That is part of Hund's rule. Electrons are in the atoms and they're filling the orbitals, but when they are, the pair of electrons, one's going to spin in one direction and one's going to spin in the opposite direction. So one spins up and one spins down. Okay, this is then the electron configuration, and this is the orbital notation for helium. Okay, I'm going to erase that now because this is what you need to actually copy and put in this spot in your notes. Okay, you should be writing it down in your notes down here. And I'm writing it up here so that I can look at the periodic chart and show you where I'm getting it from. So hopefully everybody has that. And I'm going to move on to get the next element. So the next element is magnesium. So you're going to put all of your work down here. And I'm going to fill it in up here just so I can show you what's going on as we do it. Okay. Magnesium. Find magnesium. It's right here. Magnesium is element number 12. That means it has 12 protons according to the atomic number. And if it's neutral atom, it also has 12 electrons. So I want to show where are those 12 electrons. So I'm going to work my way through the periodic table and write the electron configuration for magnesium. So I have to, it has everything that sodium it has everything that beryllium has everything that all the ones before it have. And I'm going to write all the way through down to the last electron for magnesium. So first of all, magnesium fills up energy level 1, S block, and both electrons. And then it goes down to energy level 2, and it fills up the second energy level and the S block and both electrons. We go over here, we're still on energy level 2, so we got to write it again, but now we're in the P block. So 2P, and it fills up all these spots, which there are 6 spots. 1, 2, 3, 4, 5, 6. P has 3 shapes. 2 electrons in each shape is 6 electrons, and they're located here. This would be the P1, P2, P3, P4, P5, and P6. Okay, so now we go down to the third energy level. Magnesium has, so I had to write the 6 up here. It now has the third energy level. Now we're back in an S block. We're back in an S shape, and it has 2 spots filled. And just so you understand, the S shape is the sphere, but what you have is like the first energy level S is maybe this big, and then on top of it you have a second energy level S, and it's another sphere, and it's that big, and then on top of that one you'd have the third energy level S, and it's another sphere, and it's even bigger. Okay, so that's the the electron configuration for magnesium. So what about the orbital notation? Draw my lines. You have to draw lines sort of separate these. And if you don't draw lines, and I cannot tell what you're doing, I'm not going to be able to give you credit. It needs to be obvious because I have 80 something papers to grade here. So S has one shape. So go and draw one line wherever you see S block electrons. The P's have 3 shapes. So you draw 3 lines where you see P block electrons. This would be the PX, the PY, and the PZ. You don't have to write these down underneath, but I'm just helping you to visualize, I hope. Now we're going to add the electrons in. 1 electron spins up, 1 spins down. 1 electron spins up, 1 spins down. 6 electrons. Up, up, up. That's what Hund's rule says to do. Go put 1 in each spot, then come back to the original one and double them up. Spin down, spin down, spin down. That's 6 electrons. And then S block, 2 electrons, 1 spins up, 1 spins down. Okay, this is the orbital notation for magnesium. So I'm going to give you a second, make sure everybody has that written down on their paper. Okay, now I'm going to assume that they do. If you don't, you can pause it and write it, and we'll go back on. go back from there. We're going to now do germanium. GE. Okay, so let me erase all of these guys. And, oh, sorry, I want to erase this stuff too so we can work our way through it again. Great. Now let's find germanium. Germanium is right here. Okay, germanium is element number 32. So this is going to be a little bit longer to write. Element number 32. That means it has 32 protons and 32 electrons. Where are those 32 electrons? We're going to start at the beginning again. It fills up energy level 1 and fills up the S block, S2. It fills up energy level 2, the S block, and both of them. It goes straight across. It fills up energy level 2 and the P block, and there are 6 of those. It fills up energy level 3 and the S block. Fills up energy level 3 over here and the P block. Fills up energy level 4 over here and the S block. Then it goes down to the 3 level again. And I want you to write it just like I do that. It goes down to 3, and now we're in the D block. So we got to write 3 and D, and it uses all 10 electrons. Remember, D has 5 shapes. 5 times 2 is 10 electrons, and here's where they'd be located. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3D, 10. And then it goes back up to energy level 4, and 4P, 1, 2. 4P2. All right, 4P2. Okay, now let's do the orbital notation. Draw the lines. I'm going to give a lot of room for the D's. All right, S's have one shape, so one line for each S. P's have 3 shapes, so 3 lines for each P. D's have 5 shapes, and then there's another P. Now let's go back and put our electrons in. 2 electrons, up, down, 6 electrons, up, down, 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 2 electrons, up, down, 6 electrons, up, down, 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 2 electrons, up, down, 10 electrons, up, and then down, down. It's hard to see that one. Down, and 2 electrons here. You put 1 in the first one and 1 in the second one, and this one will be empty. And that's what Hund's rule says. Put 1 in each spot before you double up. So this is normal. This is the unabbreviated form of germanium. Now I'm going to show you the shortcut that chemists like to use, the abbreviated form. So germanium still is right down here. So we just go up 1 level, go all the way to the end to argon. So we're saying germanium has everything that argon has. Okay? Everything that argon has, plus some extra stuff. So here's germanium. Sorry. Where is it? There it is. Okay. There's germanium. We went up and all the way to the end. So you're going to write a brackets for argon right there. And now germanium contains everything argon contains plus some extra stuff, plus the 4s2 plus the 3d10 and plus the 4p2. That is the abbreviated form. So that means that all of this stuff right here is inside that bracket, and we only write the new things down. And so when we write the abbreviated orbital notation, that's this orbital notation right here, we only have to write the new stuff. We don't have to write the original stuff. We don't have to write all the original, only the new stuff. Okay? So it'd be right there. Okay. I'm going to give you a second. Pause the video if you need to write that down for germanium. Sorry, I guess I should leave it there for a second. Okay, now I'm going to move on. Okay, I'm not going to do silver because silver is an exception to the rule. In fact, I don't have time to do krypton at the moment. I do have a couple more videos on this, so you can go back and watch them and do some. It gives you plenty of practice on the other tutorials. I want you to spend the remainder of the class doing the seat practice work, and I'm going to write out the answers in just a second. And so pause the video, let everybody do the seat practice. When everybody's finished, pull up the video so you can see the answers. Okay? So I'll give you a chance to do that. Okay, hopefully you're ready to see all the answers. Let's look at them. Lithium 1s2 and then 2s1. It only has one of the s's, so only one electron up. The abbreviated form for calcium, you start with argon at the very far right hand side and then add the row that it doesn't have, and that's only 4s2, and you only have to add this one up and down for the s orbital. For chromium, it's also argon, the 4s2, 3d4, so you only have 4 electrons spinning up and nothing at all in the last orbital for the d level. And then for arsenic, you also have argon, and you have 4s2 and 3d10 and 4p3, because it goes down in the middle and back up to level 4, and it's in the third position, so we have 1 electron spinning up for all of them. Okay, I hope this helps you. Good luck with your homework, and I will see you Tuesday.